Hello my dear students, this is Akash HD and welcome to the ASD Physics classes. Hope so you are doing really great. So students, in this video we are just going to continue our discussion of the previous part. In this video we are going to see electric potential due to the solid non-conducting sphere, and after that we will see electric potential due to ring also. Okay, so let's start the video. So students, as you can see very well, this is the continuation of the previous parts here. Electric potential due to a solid non-conducting sphere. You can see the diagram. If the sphere is non-conducting, then the charge will be where? The charge will be distributed inside the volume, and here we have to take volume charge density rho and all that. Okay, in case of electric field of previous video, I hope so you have seen it very well. So students, now in this video what we are going to see, we are going to calculate the potential. At which points? Different points, outside, surface, inside, and you will see that magically outside and on the surface potential will be same. So see here, let charge Q is uniformly distributed on a non-conducting sphere of a radius r as shown in diagram. You can see here, electric potential due to the sphere at different points can be calculated as here. So first one we are going to see where? At an external point. So students, here I have just taken here, let's take for example here, this point A is there and this distance I have taken r. So as you know very well students, whenever the observation point is outside, the total charge of the sphere can be concentrated where? The total charge of the sphere can be concentrated at the center. This is the center. Okay, after that what will happen at here? This is my r and this is my observation point A. And due to point charge, you know very well electric potential very well. So potential outside, or we can tell at point A, is given by, yes, 1 by 4 pi epsilon naught into Q by R. Okay, very easily. And from here you can see very well this V out is inversely proportional to R. When you will go away, potential will keep on decrease, and at infinity it will become 0. Now students, at the surface what will happen at here? You have to just put small r equal to capital R here. Okay, let's take for example here I have taken surface point B here. So what will happen at here? Now this small r will be equal to how much here? Capital R. Again I am telling, just outside. So here students, at point B or at the surface, potential is given here 1 by 4 pi epsilon naught into small q by capital R. This is. Now the main situation arises at an internal point. Where students? At an internal point here. Okay, so see here I have taken some point. This point, let's take, I have taken point D, and this distance how much here? This distance is small r. Okay, so what I will do here, from passing through this small d, now I will take here one imaginary sphere. So to calculate the potential at point D, we should know very well the relation between electric field and potential, and we know that here what is the relation as dV equal to minus E dot dr here, integration. Okay, now students, we have to put the values. This dV is equal to minus electric field. Students, if I see here at this point, if I see here, electric field will be outward. And if I talk about the area vector also in which direction? Outward direction. Not area actually, dr is there, na? So this r is there, na? dr, not area, dr. Radial vector we can tell, dr. So what will happen at here? Do you know what is the value of the electric field? Electric field inside is given by, as I remember, na? You have to also remember that here, rho r by 3 epsilon naught. Or students, what is there? 1 by 4 pi epsilon naught into Q into R by R cube. Okay, this one is there. Correct only. So what I will do here, I will just put the value here. 1 by 4 pi epsilon naught into Q into R by R cube. And here what is there? This dr is there. Now because angle between E and dr how much here? Anyhow 0 degree. Both in a which direction? Same direction. And you know very well dot product means E dot dr means E dr cos theta. Theta how much? 0. Cos 0, 1. Now students, will put the limits here. So what will happen at here? When small r equal to capital R, we'll get the which one? Surface potential. And when we are at, when r equal to capital R, surface potential. General point R, that means at point D, where we are inside. Point D is there, but okay, inside is there. So what will happen at here students? Remember that here, this integration of the D will become here V, and here Vs, and here Vin is equal to, again what will happen at here? This students, so many things will come outside. Q by 4 pi epsilon naught r cube is outside, and here integration of the r dr. R dr means r square by 2. We have to put the limits where to where? capital R and here is small r. Okay, students, so this derivation not used to come in exam, but okay, anyhow, I have just told you basics. So when you will put all these values and all, here this side V in minus Vs and all this, you will simplify this. So this Vn will come K into Q by 2r cube 3 capital R square minus small r square. This value will come. Okay, remember that value. What is K? 1 by 4 pi epsilon naught. Now students, if we are at the center, value of small r how much here? This small r will become 0. That means here if I want to find out potential at the center, very very important. What I am telling? Potential. Which potential? Electric potential. Potential at the center. So at center means what will happen that here? This small r equal to 0. So as we know very well, electric potential not potential, as V in is equal to what I have told you, K into Q by 2r cube 3 capital R square minus small r square. And at the center what will happen that here? Small r 0. That means center V naught, or you can write VC also, no problem. No, V naught or VC, anything is okay, no problem. So it will become here K into Q by 2r cube. It will become here how much here? 3r square. This will become 0. That means here we can say V naught equal to, students here, it will become here 3 by 2 K into Q by R. And what is this? This is the surface potential. That means potential at the center is how much? 1.5 times of the surface potential. Very important. Kindly remember it very well. Okay, great. Now students, after that we are going to see the graph. Electric potential versus observation point for non-conducting sphere. Again I am telling that here, see, outside value how much here? See, K into Q by R. Or remember that here, this V out is inversely proportional to R. Okay, surface, same story. What is there? K into Q by R. And if I talk about here inside, yes, that is the main thing. K into Q by 2r cube 3 capital R square minus small r square. And especially at the center, V naught or VC is how much? 1.5 times of the surface potential. Okay, so by taking all these things, we are going to draw the graph here. So students, this is R observation point, this side potential V, this is the center. Now, so you know this is capital R. So this is the surface, R equal to capital R. Here R equal to minus R. So you know very well at the center potential how much here? At the center potential how much here? 1.5 Vs. And at the surface somewhere here, let's take Vs is there. Vs. So you know very well how the graph will appear here, students. How the graph will appear? The graph will go something like this. Now very symmetrical from here. Like this it will go. And here also it will go like this here. Now this should be somewhat symmetrical. Okay, like this it will go here. Now, and students, see this one here. This line also you can draw like this. And what is this? This we used to write here Vs. So this is the graph of what? This is the graph of electric potential due to non-conducting sphere. Okay, remember it very well. If in case negative charge, this graph will shift downward. Okay. Now students, next one please. Third one. What is this third one? This one, electric potential on the axis of uniformly charged. Very easy. Let's see here. Let charge Q is uniformly distributed on a ring of radius r, which is placed in which plane? YZ plane, as shown in diagram. This is x-axis, y-axis, z-axis outside of the board. So ring is something like this here. Okay. Even the charge is uniformly distributed, non-uniformly distributed, does not matter. So you know very well, we know the formula of the electric potential due to point charge. So first we will use the point charge. Formula will write at the observation point, then we will integrate it and we will get the answer in an easy way. So see here, electric potential due to charge dq at point P on the x-axis is given here. Okay. So let's take for example students, here I have taken very small charge, how much? dq. Okay. And this is my observation point P. And this distance is how much? X from the center. Okay. And student, this is R. And what is this? This is charge. This is observation point. This distance is how much? R. So you know very well electric potential is the scalar quantity. That means potential at point P due to charge dq is given by very small potential dV equal to 1 by 4 pi epsilon naught into dq by R. Okay. Due to the charge dq. Now the total potential how much? We have to just integrate it. So see here please here. Again, electric potential due to total charge q at point P on the x-axis can be calculated here. So hence this V equal to integration of the dV, where at point P you can write no problem. So here what this will come here? K into dq by r. Okay, what are the things constant? This K by r is constant because charge and observation point equidistant, just like a birthday cap. Okay, and here what will come here? Integration of the dq. So hence students, it will become here, this Vp is equal to K, integration of dq how much here? Q, and from the Pythagoras theorem, this small r how much here? This one is r square plus x square. You can see one triangle here. Okay, so we can write here, students, this one r square plus x square, and what is this here? Square root is there. This potential is where? At point P. Now if in case, if we talk about here at center of ring, so at the center of the ring, what will be there, students? When point P is coming to point O, value of x will be how much? At the center of ring, this value of x will be here, let me write here, this value of x will be 0. So just put the value of x 0 here. So what this will come here? Hence V naught equal to K, that means 1 by 4 pi epsilon naught into Q, put x equal to 0, square root of r square means how much? R. So this is the potential at the center of the ring. I hope so you have understood all this very easily.